In the previous tutorial, we showed you some simple applications for logical negation. Especially, you are required to understand the logic for double negation. Okay, if you're not so confident, please refer to the previous video. And for the current video, we're going to show you some simple application for logical conjunction. Okay, so for logical conjunction, the very common way of doing that, using it, is by specifying a range of numbers. Okay, now let me show you over here. So conceptually, again, let's draw the number line over here. So let's say this is number line. Let's say over here, let's say we want to know if the user's enter integer is actually within a particular range. Let's say, for example, let's say between 1 and 10. Let's say, how about that? So let's say we have 1 over here and we have 10 over here. We want to make sure inclusively. So for those of you who actually learned about calculus in high school, so we are really specifying the closed interval 1 and 10. Okay, that's what we are trying to do over here. Okay, and of course you can make any of the side to be open interval as well, but I'll leave that to you as an exercise. Okay, so now what we can do is over here, the target is to make sure the number should be within 1 and 10. Let's see, mathematically speaking, how that can be specified. Mathematically speaking, that simply means, let's say the user enter integer is simply just I. Okay, so that means I should be larger than or equal to 1 and less than or equal to 10. Okay, that's what we have. So now, how do we translate this to Java? It's very easy. First of all, how do we translate this operator over here? Well, we have less than or equal to, and over here we got less than or equal to. And now another issue is the relational operator over here is a binary operator, which means when you apply this one here, it must be applicable to both 1 and I. Okay, nothing else. So you just cannot write, if you write 1 less than equal to I and less than equal to 10. In Java, this will not simply compile because now less than or equal to is actually applying to 1, I, and this, right? It's not a valid binary operation anymore. So you actually 3 operands, right? This is simply not correct. Okay? You cannot write this in Java. What we can do is we can split it into 2 things. So now you can say, logically speaking, this is simply just equivalent to 1 less than or equal to, let me just write it in Java, less than or equal to I. Okay, that's the first part over here. Not only that, and also I must be less than or equal to 10. And now here we can use a logical conjunction to combine them. You understand? Not only that, I is larger than or equal to larger than or equal to 1, which is the beginning of the interval, and also I is less than or equal to 10, which is the end of the expected interval. Okay, so we use logical conjunction over here. And let's illustrate what the correct behavior looks like. And then I will show you what if you actually use logical disjunction over here, which is completely wrong. But I have to understand how wrong it is. Okay? So what I would do now is, so let's understand, assuming that you already understand the logic over here, so let's see how we can do it. Let's now right click on the project and say new class over here. So logical operation app 2. Okay, let's say 2a. The 2a is going to be the correct version, but for 2b, I'm going to show you if you use the wrong logical operator, then what's going to happen. Okay, the logical operation app 2a, and with the main method here, and then I say finish. Okay, and now let's see what we can do over here. Okay, so now again, you can declare the scanner, control space to import it. Input is new scanner, and then system.int, which denotes the keyboard for the user. Oops, so I accidentally hit it. You don't have to worry, just say cancel. And then over here we can say input.close as the last line. Okay, let's now do some job over here. So prompt the user for some integer, system out.println. Okay, you can say enter an integer between 1 and 10. Okay, and then we can ask the user to say integer I, again let's say I, is assigned to input dot next int. Okay, they're gonna enter some integer. And then what we would do is, let's see whether it's between 1 and 10. So again, you can either do a variable, or you can actually write out the logical expression directly on the within the print statement, as I showed in the previous video. Let's just use a Boolean variable, okay? So Boolean, okay, is between 1 and 10. Okay, basically you can see that compound word, the first word, all lower cases, capitalized and capitalized. Okay, 1 and 10. Or you can simply you can either say it's between 1 and 10, or you can say is in the expected interval. Okay, it's completely up to you how you name the variable. I'll leave it to you. Okay, you have the freedom to choose the variable name. Is between 1 and 10, I would say 1 less than or equal to I, n% for conjunction, I less than or equal to 10. You can see that somehow this looks very much like the corresponding math as we tried to explain before, right? It looks very much like it over here. Very much like it. It's just that we're going to split it into two parts and using conjunction to combine them. Okay? Of course, if you prefer, it's completely up to you. I'll write it here. You can also write I larger than or equal to 1. This part here is completely equivalent to 1 is less than or equal to I, right? When you say I is larger than or equal to 1, it's as if 1 is less than or equal to I, right? And also you can say yeah, I larger than or equal to 1, and also I less than or equal to 10, for example, right? You can feel free to change the operands if it works, okay, if it makes sense mathematically, okay? So now let's try to see if this will print out the good results, okay? And with this system, out dot print line, and then we can say the number you entered, which is I, is between 1 and 10. Okay, let me just maximize this for you. Okay, so we have more space to type. Okay, it's between 1 and 10, and then we're going to say whether that's true or false, right? And then, by the way, if you already declare a variable in Eclipse, you can use some code completion feature. So you can just type the first few characters for the variable is, and then control space. It's going to give you choices for the menu. You can choose it. Okay, it's between 1 and 10. Okay, so now let's see if we can get the correct result, and then I'll trace the program together with you. And then we'll see some wrong version to really more appreciate that choosing the right logical operator is crucial. Okay, so now what I would do is I will simply just execute the program over here. So right click on this class and then run as Java application. Okay, so now let's give one value that is going to give you true. For example, it's between 1 and 10. If I say 1, of course that will be true. And then if I execute again, if I give 5 in the middle, that will also be true. If I give another boundary value, if I say 10, it's going to be true. Now let's try something that will give us false. For example, 0 would be false, right? And also if I try -1, it would be false, right? If I try, for example, 11, that would be false. And try something bigger. If I try 15, it will also be false, right? Okay, so it seems to be working. That's kind of the testing procedure I would like you to really derive for yourself. Always you're responsible for the correctness of your program. How do you ensure the correctness? Test it, okay? So now this seems to be working. So what I want to do now is I want to basically, okay, right click on logical operation app 2A, and then you will simply say copy, okay? And then right click again and say paste. And we want to create an alternative version and say 2B. Okay, so now for version 2B, let me just close 2A. Okay, and let's open 2B over here. So now what I would do is I would say this version chooses the wrong logical operator. Okay, chooses the wrong logical operator, and we want to see why it would be wrong. Okay, and now what we will do is we'll say change that to OR. Actually, before I do this, maybe I should actually show you some tracing for the previous one, the correct version. Okay, and basically this is the wrong version. The only way you can see this is 2b over here, which is wrong. The only thing I changed from 2a was I changed from conjunction to disjunction. This is wrong, okay? If you want to specify some interval. So what I would do now, can we just go back to 2a, the correct version? I want to trace the code with you first, and then we'll go to the wrong version and trace it again. So now we simply just go to app 2a. So this is the correct version, okay? And now what I want to do now, let me take a snapshot of the program over here, and then we will trace it together. And then I'll make it very explicit on the notes. Okay, so now let me go to iPad over here, and then I will simply copy and paste the code. Let me just use a new page. I think that'll be cleaner for you. Okay, so now let me copy and paste the code over here. Okay, let me just wait for the computer to respond. Okay, and then I'm going to paste it. Okay, so let me first of all say that this is the correct version. Okay, this is the correct version where we actually used a conjunction. Okay, this is the correct version. The wrong version uses a logical disjunction, which I will copy and paste in just a moment. Okay, let's just try very quickly. Let's say two values. Okay, so now let's say one value that will make it true and one value that will make it false. Okay, let's try that. So what I can do, let's say, let me just write it down. So let's say test number 1, we're going to try the value for 5, the middle value. And for test number 2, I'm going to try something that will make it false. Let's say something that's simply too small. Let's say -2. Okay, so these are the two values I'm going to test for the correct and wrong version, right? The correct version is going to produce expected value for both cases, but the wrong version is going to fail to produce the expected value, of course. So now let's try test 1. So for test 1, can I just use green? Okay. So now for the test 1, we're going to say enter an integer between 1 and 10. Okay, let's say we go to the second line. The user is prompted now for the integer. Let's say the user actually entered over here. Excuse me. So the user actually entered over here. Let's say test 1, it will be 5, right? Let's say they enter 5. And then, so that means 5 will be stored inside the integer variable 5, integer variable I. So now let's try to evaluate the conjunction. Okay, let me just erase this. Okay, over here. So now we know that for test number 1, I will be 5, and I will be 5 over here. 1 less than or equal to 5 will be true. All right, I'll just say T for true and F for false. And then 5 less than or equal to 10 will be true. And we know that true and true is the only case where conjunction will be true, right? So we know that overall, true and true is going to give us true. So that means the true result is going to be stored inside this variable over here. So that will be true. So now when we say the number you enter, which is I, and in this case it is 5, right? It's in between 1 and 10, and this is the Boolean value that we just store into this variable over here. So it's going to be true. Okay, this one is rather straightforward, right? So let's try to do another one. Okay, let me just make it fresh for you. Okay, now we're going to have a second test case. Okay, for the second test case over here for the correct version. So we'll talk about -2. Okay, so now again for the first line, we say enter an integer between 1 and 10. And now for the user, let's say the user keyboard, they enter -2, for example. If they enter -2, that means -2 will be stored inside this variable I, which is -2, right? So that means I over here, that we talk about, is going to be -2 for test number 2 scenario, right? So now, 1 less than or equal to -2 is false, right? Okay, hopefully you can see that, right? 1 is a positive number and -2 is a negative. How can a positive number less than or equal to a negative number, right? So that's false. And -2 less than or equal to 10 is actually true, right? You can see -2 less than or equal to 10 is true. Hopefully you can see that, right? So now, what we are trying to evaluate is false and true. And because we know that for the definition of a conjunction, as long as one of the operand is actually false, overall is going to be false, right? So that means over here, the overall result for this will be just false, okay? It's just going to be false over here. So that means false is going to be stored inside this particular variable over here. And then when we say the number you just entered, which is -2, in this case, is between 1 and 10. And now in this case, this variable over here has been stored the value for false. Okay, you can see in case number 1, we actually get true. And in case number 2, we get false, as expected. Okay, that's a tracing for the correct version. So this is the correct version. Okay, so now let's now go to change the we already changed the operator. Let's go to 1B, which is wrong version, and see why it is wrong. Okay, let's verify that it is wrong from the Eclipse, and then we'll do the same kind of tracing with you together. Okay, so now let's go to version 2B over here. You can see that the only thing we changed from 2A was disjunction. Okay, it is wrong because when you want to specify a range of a interval, you must use conjunction. Okay, of course you don't memorize this rule, you just understand it logically. Okay, so now we got disjunction over here. Okay, let's do exactly what we the cascades that we did. Let's do 5 and -2. In the case of 5, we expect true. In the case of -2, we expect false. Okay, let's see if we really get this result. If we get these two results the same, that means using disjunction is okay. If we don't get the same result, that means disjunction is not okay. So now what we'll do is we'll execute 2B over here. So right click on this class, and then you'll say run as Java application. Okay, so now let's do the first case. It'll be 5. Okay, if I say 5 over here, it gives us true. That's okay. That's as expected. But now let's re-execute it. The second number will be -2. If I do -2 over here, it's going to give me actually also true. So that is wrong. So for the test one, it seems to produce the same result as in conjunction, the 2A. However, for the second case where we are expecting false, the wrong version is producing true. Okay, so this is where we have some logical error. Why logical error? Because version 2B, there's no red cross over here. It compiles, no syntax error, no type error, and it doesn't crash. However, the produced result is simply not right. So what can we do? Let's try to trace the program and see why it is wrong. Okay. Again, what I will do is I'm gonna trace the program together with you. Okay. Temporarily, let me take a snapshot. Okay, let me just get rid of this so we get a better line. I'll undo it, don't worry. Okay, so now what I will do is I will take a snapshot. Okay, I will get this part of the code and then we'll trace it with the same 2 test inputs, and then let me undo it. Okay, so you can still keep the comment on your screen. And now let's go back here, the same. And now what I will do is I'm gonna put on the same page so you can do the comparison. Okay, let's wait for the computer to respond and then we can paste it. Okay, let's wait a bit. Good, now let me paste it. So this is still disjunction over here. Let me just see this again. You know, let me try to do a screenshot again, beg your pardon. Let's see. Somehow it was not really properly copied to the clipboard. So control, okay, let me do it again. Please work. Okay, I will take a snapshot of this. Okay, good. And now let me go back here. And then I will paste it. It doesn't seem to work. Okay, let me do it again. Okay, and then come back here, and then I'm gonna paste over here. Okay, hopefully this time it's gonna work. Okay, it seems like it's reacting. Okay, I'm gonna paste over here. Okay, we do have the correct version. Okay, sorry for the time being wasted, but it's gonna be worthwhile. Okay, so what I will do is I'm gonna do this one here. Okay, that's gonna be test number 1, and then let me annotate it for you. So this is the wrong version. So this is the wrong version. Before I forgot, let me just go back to my code over here. I will undo the comments over here, okay, so you don't lose it. Okay, so now let's see, this is the wrong version. The reason that it is wrong is because we're using disjunction rather than conjunction. Okay, so now what I will do is let's go over the 2 test cases, okay, and see why. In test 1, it seems to produce true, but in the second case where we expect false, it's still producing true. Okay, so now in the first case, let's say we're gonna try. So now let's try. Okay, when we execute this line, prompt the user for some integer, and if the user enter, let's say 5 in this case, if the user enter 5 over here, and 5 will be stored into I, and then that means, let me just erase this part here to avoid confusion, and then we have I here being 5, I here being 5 as well. Okay, 1 less than or equal to 5 will be true, and 5 less than or equal to 10 will also be true, right? And then true or true over here, true or true. We say that at least one of them is true, disjunction will just be true. Okay, so this will just be true. So it's between 1 and 10, it's going to store this true result over here. So now when we say we will print out the number you entered, which is 5, it's between 1 and 10, and now in this case the store result is actually true. Okay, this is consistent with the correct version. Okay, that's fine. Okay, but now we want to see why in the second test case where we are actually expecting false, it wouldn't produce false actually, but let's see why. And then I will explain to you conceptually what the insight is for this. Okay, so now what I will do is I'll paste the same fragment of code again, and then I will illustrate the second case together with you. Okay, let me just make some space over here. Okay, that's the second case. So now let's think about -2. So now we execute this line to really prompt the user for the input, and then let's say they enter this time, let's say -2. That means -2 will be stored inside the I, and then this is -2, and this is -2. Now 1 less than or equal to -2, we know that previously it should be false, right? So I'll put false over here. And -2 less than or equal to 10, and we know that it should be true, right? The same. Both relational evaluation are just the same. It's just how we combine them together is really the issue over here. Okay, so now we are using disjunction, which means false or true, versus false and true in the correct version. And we know that at least one of them is true, so that means overall it's just going to be true. And now we know that this is just going to be true. That's the problem, right? Because you want to say, you want to insist not only that it should be larger than or equal to 1, but also it should be larger than or equal to 10. It should not be a conjunction, should not be a disjunction, not or, it should be and. That's really the problem. Okay, so now when we store this wrong value over here, which is true, okay, in that case, so we say the number you just enter, which is -2, is in between 1 and 10. In this case, is in between 1 and 10 will just be true. So this is inconsistent with what we expected from the correct version. So this is simply just wrong. So that means the way we use disjunction here is wrong, the way we use it is wrong. Okay, hopefully you can see that. I try to make it as clear as possible, so that means you really have to follow through the reasoning over here, right? It's really important for you to remember. When you want to specify the ranges, you don't really use disjunction. Okay, that's simply just wrong. It's a logical mistake. Okay, one more thing to say. Okay, so now when we say, think a little bit more just as a conclusion for this current video. So now let's say again we have the number line over here. Okay, so now what does it really mean visually when we say 1 less than or equal to? When we say 1 less than or equal to I, or I less than or equal to 10. So what does this really mean when we got disjunction, right? That's what I want to illustrate. Let's say this is 1 and this is 10. Or means either way is okay. Let's think about what it means when we have over here the orange part. 1 less than or equal to I, that means that means basically here. So I can be anything that's larger than or equal to 1, from 1 until conceptually infinity over here, right? And now when you actually say I less than or equal to 10, that means I can be basically, including 10, it can be anywhere that's less than or equal to 10. All the way conceptually down to minus infinity, right? So now we are saying either the orange one is okay or the blue one is okay. So now you can think about basically what we are really saying over here. You're basically saying it's always true. So this logically can be reduced to just true, which means any number you give is always going to satisfy either this or that. So logically speaking, this disjunction expression over here is not very useful. Compare with if we actually say 1 less than or equal to I and I less than or equal to 10. That one is actually really specifying this particular range. However, if you use the wrong logical operator, it simply can be reduced to just true, which means any number will satisfy. That is why, in this case, even though we are passing -2, you can still satisfy the disjunction over here. Okay, please understand this particular reasoning over here, and you're expected to know not just what the right operator to use, but also if we use the wrong operator, can you actually explain why it is wrong?